Our next two speakers, please come forward, are going to be enlightening us about some work they've been doing with geolocation. Okay.
Yes.
I love the combination of experience and youth and time for the most part, right? So I think the next two tools are going to be talking about a couple of very interesting tools. And what I think it's this type of combination of having different parts of the community, more experienced people who have the ability to lead the path, right? And then young people who are eager to investigate more, to invest time, and invest in your future. I think that's a winning combination. So thank you guys for joining us today.
Thank you too.
And the floor is yours.
Thank you.
Thank you.
Hello, everyone. Thank you, Jess, for your introduction. It's a pleasure for me to be here with you this afternoon. I would just say, my name is Roberto Consalvi. I'm a computer science engineer from Italy, and I was a digital forensics expert since 2001, 24 years. So what about this project? What was the idea behind Go Location project? It all started on February 2024. A driver was driving on a Sicilian highway, and he was driving fast, too fast. When he realized that in front of him there was a truck standing on the highway in the entrance of a tunnel, it was too late. He tried to hit the brakes, but there was no more time. The speed was so high and the impact was violent. The car went under the truck and the roof opened like a can of tuna. And sadly, the driver died. The public prosecutor office began investigate on this case to reconstruct the dynamics of the accident, as there were no cameras and no witness, and gave me the task to examine the driver's cell phone to see if it was in use during the trip. While examining the phone, I discovered that the Google Maps app had been running during the trip. So I asked to download the Google Takeout data and of the driver account, from the driver account. And when I examined this file, the file containing the Google location data, I found a lot of useful information for my task, for my investigation. First, obviously the positions in terms of latitude and longitude that Google detects every 5 or 6 seconds. Then the speed at each position in meters per second, and the heading of each position in degrees from the north that indicates the direction of motion, the accuracy of the detection, and last but not least, the information about the the information of the so-called Google activity. The most useful information, the most useful activity that for my case, for my investigation, was the so-called status, the status of the device. A still status indicates that the phone is in its stationary position, like when the phone is sitting in its holder. A tilting status, instead, means that the device was rapidly moved or picked up from its static position, like when you grab the phone from the desk. So while examining the data, I found that there was a detection of still status until the moment of the accident. At a certain point, a tilting status was detected, and that was the exact moment of the crash. 3.3 seconds later, that's the moment in which the phone flew out from the opened roof of the car. 3.3 seconds later, another still status was detected. That was the moment the phone flew flew back on the road at 33 meters away from the accident site. And 45 minutes later, another tilting status indicates that the phone was found and picked up from the ground. I asked, and the police, this event was perfectly confirmed by the policeman who found the phone and picked it up from the ground. So I could conclude that the phone was not in use during the trip. And I found the exact moment, I could find the exact moment of the accident. So my goal was achieved. But could I represent all this information on a paper report for the prosecutor office? And here is the idea of Google location. I found a software library named Leaflet, available for JavaScript and Python. And I used it to represent all this information on a geographical OpenStreetMap. Each position has a marker oriented towards the direction of motion. I developed an user interface who allows the user to choose the observation period, which markers show and which not, whether or not to show inaccurate surveys, zoom in and out in the map. And additionally, I allowed the user to open as many pop-ups as they want, each one containing all the desired information of the survey. Other apps, like Google Maps, allow the user to open only one pop-up at a time. When you open a pop-up, the previous one closes. So that's all, because I take a screenshot of the Google location map with all the desired information and pass the image into the paper report. But Google, a few months ago, changed the way it stores movement position, moving data from the cloud to devices. And so my friend, Professor Hugo Lopez of the University of Bari, asked me to share the source code of this project with his student Ludovico, as he could adapt it to the new Google file location. And so Ludovico, building on my project, made it his thesis. That's all. To you, Ludovico, thank you very much for your attention.
Thank you for the presentation, both of the presentation.
Show the map.
Now you show your map. This is the road that the crash that is say. We can see every marker on the road. So digital localization is one of the most important search in forensic computing, because it connects digital events to space-time coordinates. Google Maps, everybody know it, is active since 2005, and with 1 billion monthly users, is one of the most app for the real-time navigation and multimodal route. Until 2024, Google stored the location data only on cloud, on the Google Takeout service, but from 2024, for privacy reasons, location data is only stored in the device, so we must have a physical access to the device to export the file. For export the file, we must have the app open, go to user access, profile, timeline, and export the file. There are two requirements. Location history must be enabled, and Google Maps app with location access permission. So the file is a JSON file, and it has three main segments: visit, activity, and time path. The first segment is visit, that describes a long stay in a specific place, like work, home, or this hotel. Activity represents the movement between two places, and the transport mode, on foot, by car, on tram, on plane, and the distance. And the most important segment was time path. Time path is the most important segment because it is very important for the visual reconstruction of the route. So there are a lot of missing fields, like accuracy, altitude, speed, heading, and there is another limitation, that there is not a digital signature or integrity check, like double hash or encryption. So the project was born from the need to analyze the new location data and understand the structure of the file and explore its forensic potential. So the project was a client-side web application and don't need a backend. The project is only on HTML, CSS, and JavaScript, and the project is open source. So we can see two different view modes, like OpenStreetMap and Satellite, and how every marker make a route with the GPS data. So we can see every marker. So the marker is every time path point, and every marker is clickable, as say my coworker first. And when we click on a marker, a pop-up opens with details, and we have a panel to select multiple markers. Every icon changes for if the marker is in the segment visit, we have a stop user icon, and if the marker stay in the activity segment, the marker change in the change for the transport mode, like now this is a car or a bike. And every marker, there is no heading, so every marker rotates to the next point of the map. So this project shows that this file is most important, also without a technical field. And the future update will be compatibility with other formats like Android, and integration of multiple files and multiple apps like Apple Find Mine. And we want to we want to maintain the project as an open source. Thank you for watching.